of linked lists the source mentions is circular linked lists. What makes them circular? Sounds obvious, but
It is fairly intuitive. In a circular linked list, the chain doesn't end with a NUL pointer. Instead, the very last element in the list is linked back around to the very first element, creating a continuous loop or a circle.
no NUL terminator.
Exactly. The source mentions there are two main variations following the patterns we've seen: circular singly linked lists and circular doubly linked lists.
Okay, so in a circular singly linked list, the next pointer of what would normally be the last node doesn't point to NLL, but instead loops back and points to the very first node, the one that the head pointer is referencing.
That's exactly right. It's like a chain where the final link connects directly back to the initial link, forming a closed circle you can traverse round and round in one direction.
And I guess in a circular doubly linked list, you complete the circle in both directions.
Correct. It's like a regular doubly linked list, but with two additional connections forming the circle. The next pointer of the last node points back to the first node, and the previous pointer of the first node points back around to the last node. So you can go round and round, forwards or backwards.
Huh. Why would you want that?
It can be useful in situations where you want to treat the list as a continuous loop, maybe for things like round robin scheduling or managing a buffer where you wrap around from the end to the beginning. The source notes that there are specific design considerations and activities related to working with these circular structures effectively.
Interesting. So in a circular list, you could theoretically keep traversing indefinitely if you just followed the pointers, right? You'd never hit NULL.
That's right. You'd need some other way in your code to know when to stop your traversal. Perhaps by checking if you've returned to the head node after one full loop, or by keeping a counter or some other condition relevant to your task.
Well, this has been a truly eye-opening deep dive into the world of lists as data structures. It's amazing, really. We started with the everyday idea of just an ordered collection, like a shopping list.
Yeah,
And we've uncovered how these seemingly simple structures can be implemented in really clever and diverse ways inside a computer, using either those contiguous arrays or this more flexible linked memory approach.
it's quite fundamental stuff, but yeah, the details matter.
We explored the trade-offs, how memory is used, the efficiency, that time complexity thing for different operations like adding, removing, finding items for each approach. And then we navigated through the intricacies of singly, doubly, and even these circular linked lists. It's quite remarkable how much complexity and ingenuity lies beneath such a fundamental concept.
Absolutely. And understanding these foundational structures, even conceptually, is really key to appreciating how efficiently computers manage and process the vast amounts of data in, well, pretty much all the applications you use every day, even if you're not consciously thinking about arrays or linked lists or pointers working away behind the scenes.
Yeah, it's happening under the hood all the time.
Definitely.
So, to leave our listeners with a final thought to maybe chew on, considering the strengths and weaknesses we've discussed, the fast random access of arrays versus the flexible insertion deletion of linked lists, the whole shifting versus pointer manipulation thing, can you think of a real world scenario, maybe an application or a type of data, where one of these approaches, array based or linked list, might be significantly better suited than the other? And crucially, why?
Ooh, good question to ponder.
Yeah, think about situations where maybe you're constantly adding and removing items right in the middle versus other scenarios where you primarily need to quickly grab an item at a specific position, maybe position 1 million very fast. Which structure would you reach for and why? Something to think about until our next deep dive.